Kia ora and welcome to video 19 of Agile Algebra. In this video we're going to look at a problem involving a geometric sequence, and it's going to be led by another former student of mine, Logan. Logan achieved scholarship calculus back in 2019 after a few years with us, and he was very close to an outstanding, such was his intelligence and overall strength in calc. He also, during his time at MAGS, really enjoyed maths problem solving, and was often involved in the Olympiad competitions that ran at the time. So without further ado, here's the problem, and I'll let Logan take it from here.
Alright, hello everyone. Today I will be showing you how to solve this question that you can see on your screens right now. Now, a lot of you probably won't have heard of a geometric sequence before, so you may be a bit confused. But whenever you see something like this that is unknown to you, it is always best to take it one term at a time and write it out in plain and simple form, and then from there see what you can do with it. Now, in this example, we start off with 1,000 as the first term of our geometric sequence. But it doesn't have to be 1,000. You could have any number at the start, and it would still be a geometric sequence. So we can call our first term k in general. Now if we look at the second term, it's going to be the term before it, which is k, multiplied by our ratio, which in this example is 1/2, but in general is r. So that means the second term can be written as kr. Now the third term is going to be the second term multiplied by the ratio again. So in this case it will be kr times r, or kr squared. And likewise the fourth term is going to be kr cubed, and so on. Now if we look back at the original question, we have the average of the first 3 terms of the sequence, and we have the average of the next 6 terms, and we need to make those equal to each other. So have a think about how you could write that in an equation using terms like these. Feel free to pause the video, and I will give the answer in 5 seconds. So this is what we get here. We have the first 3 terms of our sequence, divided by 3 to find the average, and then we have the next 6 terms, all divided by 6 to find their average. Now if we want to start working on this and try solving for r, the first thing we should do is get rid of those denominators, make them look a little bit nicer. So we can do that just by multiplying by 2, or 6 rather, and that will give us this equation here. Now, if you have a look closely, you can find this k plus kr squared kind of term twice on this side of the equation here. If you take out a factor of r cubed from these first 3 terms, and a factor of r to the 6 from these next 3 terms, you'll get this. And now it's quite obvious that we have k plus kr squared here, and here, and here. Now, we can rearrange things slightly to get 0 on one side of the equation, and now we can factorize out this quadratic term, and it will give us this. So now we have 2 parts of this equation being multiplied together to equal 0. So that means that we only need one of them to equal 0 for a solution to be valid. Now let's look at what happens if this first part here is equal to 0. It may not be immediately obvious to all of you, but this is actually just a quadratic. Because if you think about it, r cubed is r cubed to the power of 1, and r to the 6 is r cubed squared. So this is a quadratic with r cubed as our variable rather than just r. So now we can put this into the quadratic formula, and that will give us this, which we can simplify and simplify again. And here we find that r cubed has to be equal to 1 or negative 2, which means that r is going to be equal to the cube root of 1, which is just 1, or the cube root of negative 2. Now, looking at the second half of our equation, this is much more obviously a quadratic. So if you want, we can rewrite it in a slightly more familiar form, and we can take that and put it in the quadratic formula, just like before. And soon it becomes quite clear that we have a negative number under the square root here, which means there are going to be no real roots. So that means that we have two possible values of r. We have r equals 1 and r equals the cube root of 2. Thanks for watching, everybody. Don't forget to hit like, hit subscribe, smash that bell, and have a good one.